Right. In the last video we looked at how we went from a BNF into making some Bison rules, and on building that Bison file we had some shift reduce conflicts. This video looks at how we can eliminate those shift reduce conflicts and go on and debug the grammar using Bison. So we're starting from the point where in the command prompt we've just run Bison with 3 shift reduce conflicts. Well, the first thing that's actually useful to do is if we go to the frequently asked questions file for the coursework, question number 7 says I've got shift reduce errors in my Yak Bison grammar, how do I locate them? It says you have to turn on the verbose output for Bison, which is the -v parameter, and then it says it generates a file called .output, which in the case of a grammar called Pascal-like.y will make a Pascal-like.output file, which we can then read. And it points at a binary operator and dual recursion as being part of the problem, so we can see if that is in our case. So what we have to do then is go through Bison with a minus verbose rule on this grammar. We get the 3 conflicts as before, but we make a file called Pascal-like.output. Opening that file, we can see state 32 caused one of the errors and state 34 caused another. So if we search for state 32 here, that's the if statement, and we go on a little bit, and state 34, which has 2 of the errors, is this binary operator surrounded by expression, which was not unexpected. So here we are in the grammar, we've got an expression, is an expression, an operator, an expression. So the suggestion in the FAQ file is we change one of those to be value, which is also one of the definitions of expression, and save the file. So if we quickly click on here, it shows how it's been rewritten to take whatever that thing is and put it on the left hand side of the operator. It actually is the same language, so we can rerun the Bison, and now we've only got 1 shift reduce error. So I expect that's the if statement, so we could go back into Pascal-like.output. We read it from the disk and go to the top of the file, and we can see it's still state 32, which is now this if statement. Now we could go, why is this if statement, this Pascal-like language, causing a shift reduce error? That's because it's an algol-like language and it has the dangling else problem, which hopefully you learned about when you did the left and right derivation trees, and you realised that dangling else causes a problem in algol-like languages. There are many ways to fix it in different languages, but what we'll do is we'll just remove that from this language just so that we don't have the problem, so that we can move ahead. So if I now go back to Bison, we'll see, having got rid of the dangling else, having got rid of the double recursion on the binary operator, we now have no shift reduce conflicts. We have an unambiguous language. So what we now want to do is make this run. So we need to now run the Bison together with the flex. So if we run flex of Pascal-like.l and then Bison without the -v because it's okay on there, the other thing we've got to do is we've got to include the output from flex into Bison so they're linked together, and we do this by putting a %% at the end of the file, and in this last section we put include flex.yy.c. carriage return, and we save that. And we got to rerun Bison again because we've edited the Bison file. That links together the output of Flex and Bison. So we can now build that with GCC, and we can make an output called parser.exe, and we can build the file it makes, which is called pascal-like.tab.c, and we can do -lfl. Now we don't want the -d print in the GCC, which we did when we were running Flex on its own, because we're not debugging the print, we're actually getting the return for the tokens. Now it's got lots of errors which could panic you, but if we go back and look at the errors, we'll actually see it's flagged up lots of our tokens which happen to have the same name as reserved words in the C programming language, so we obviously can't compile them with a C compiler. So that's a particular problem for languages which are like C, so we have to disambiguate them. So having the names of tokens with the same name as reserved words in C is a bit awkward. We can change those. One of the ways is to make them into uppercase words, or to put something on the end. In this particular case, I'm going to put something on the end of the tokens. So if I go to pascal-like.l and I rename the tokens, and instead of begin, I call begin hyphen, I put underbar t, just to stop them being reserved words. Save that. And then when I import these tokens into the Bison, I have to put the underbar t on as well. But that says in the SPL we don't necessarily need to do this because we use the uppercasing technique. Then we have to go through each rule that uses one of these tokens as a terminal symbol and put the underbar t on each one of these reserved words, begin, end, if, while, and do. So we can save that now, and we can build it with Flex as we change the Flex file. We can build it with Bison as we've changed the Bison file. I've made a typo there, which I'll just fix. I forgot to put the T in. And then we can build with the GCC line. Now it's failing to build again, and it's saying undefined reference to YY error. But this is actually another one of the standard things. Question number 6. When I compile my Yak Bison code, I get there a message YY error not found. That's because we've got to have a main program. And it says just copy this main program from what we did in the calculator, arith.c. So I can do that. I can find my file arith.c, and I can save that to a file pascal-like.c or any name like that, and there we are. So I can just change my GCC line to include a build of pascal-like.c -lfl. And now we've built a parser. So we need to test the parser. So we can test the parser by just running the parser, and we can give it input from, and I happen to have made a little example program of the Pascal-like language that I can give it. I think I called it example program. Test program. I'm going to type it right. And now the parser has parsed that test program, but nothing is printed out. We don't have any proof that it works. So what we need to do now is turn on the debug mode for Bison, or the test mode rather, and that shows that on question number 8, how do I turn on the test mode to allow me to debug that? And it says I have to use the T argument, where I previously used the -v argument for Bison, and we have to add these few lines to turn on the printing into my main program, which I've just made earlier. So I can go down to my main program, I can paste in those lines of code and save my main program, and I can rerun it through Bison with -t. I don't need to run it through Flex because I haven't altered the Flex files, and now I just have to go to my GCC line. I do have to add -d yy debug because I've used another flag in that main program to turn on the output, and then if I run it on my test program, I get a whole load of output which I can scroll through, and it's showing me which token it reads, and which rules. So it says it's found an expression, it's found an assignment statement, it's found a statement, and it goes all the way through, and it says I found a program, no end of input. That's actually worked. So that's how I've debugged my program.